Hello everyone, myself Dr. Ashalata Kunis. Now we shall discuss about point of inflection and some problem. We have already discussed about point of inflection, that is a function is said to have point of inflection d square y by dx square equal to 0 and d cube y by dx cube not equal to 0. Okay. So we'll discuss some problems on concavity, convexity and point of inflection. First one, show that y equal to e power x is everywhere concave upwards. Consider the given function. To differentiate this with respect to x, you will get e power x only. Again differentiate, find the second derivative. D square y by dx square is nothing but e power x. We know that this is always positive, which is greater than 0, which implies d square y by dx square is always positive. That means greater than 0. This implies if d square y by dx square is greater than 0, then that implies the curve is concave upwards. Next example, show that the curve y equal to log x is convex upwards every way. So, convex upwards means d square y by dx square is less than 0. Now, y equal to log x, differentiate twice. First derivative, you will get 1 by x. The second derivative is minus 1 by x square, which is less than 0. So that means d square y by dx square is always negative for all values of x. Therefore, this curve is convex upwards every way. Next problem. Find the range of x for which the curve is concave upwards or downwards. If the given curve is or the given function is y equal to x to the power of 4 minus 6x cube plus 12x square plus 5x plus 7. Now differentiate this twice, find out d square y by dx square. That is, the first derivative is 4x cube minus 18x square plus 24x plus 5. Again differentiate this, you will get 12x square, it's minus 36x plus 24. Now take 12 common, you will have x quadratic equation x square minus 3x plus 2. Now find the factors for this, it's nothing but x minus 1 and x minus 2. Now consider d square y by dx square greater than 0, which implies we know what is d square y by dx square. It's 12x minus 1 into x minus 2. This is greater than 0, which implies, this implies either x minus 1 greater than 0, comma x minus 2 greater than 0, or x minus 1 less than 0, comma x minus 2 less than 0. Okay, which implies here is some mistake. This is not less than, this is greater than. X minus 1 greater than 0, comma x minus 2 greater than 0. If this happens, then this is the product of these two is greater than 0. Or otherwise, if x minus 1 less than 0, that means negative, x minus 2 less than 0, again negative, then what is the product of this two, negative into negative, then that becomes positive. Okay, if this must be greater than 0 means either these two both are greater than 0 or both are less than 0. Okay, so which implies, look here, if you transform 1 to RHS, you will have x greater than 1 and for this x greater than 2, or x less than 1, comma x less than 2, which implies x greater than 2 or x less than 1. Thus, d square y by dx square greater than 0 in the interval minus infinity to 1 and 2 to infinity. Hence, the curve is concave upwards in the interval minus infinity, 1 and 2, infinity. Further, d square y by dx square less than 0 implies d square y by dx square means 12x minus 1 x minus 2, which is less than 0. Okay. Now, this product is less than 0 if x minus 1 greater than 0 and x minus 2 less than 0, or x minus 1 less than 0 and x minus 2 greater than 0. Okay, positive into negative, negative, negative into positive, negative. Okay, which implies x is greater than 1, x is less than 2, or x less than 1, x greater than 2. But this is not holds good. X less than 1 and x greater than 2, this does not holds good. Therefore, we have x greater than 1 and less than 2. Therefore, the interval is for d square y by dx square less than 0. The interval is 1, 2. Therefore, the curve is concave downwards in the interval 1, 2. Now, we shall find out point of inflection. I have already told you the definition or the condition for finding the point of inflection, that is d square y by dx square equal to 0 and d cube y by dx cube not equal to 0. So, now equate this to 0. So, you will have x minus 1 equal to 0 or x minus 2 equal to 0, which implies x equal to 1 or x equal to 2. Okay. So, now find out the third derivative of this. We already have the second derivative, that is nothing but this much. So, find out the third derivative. It's 12 into 2x minus 3. Okay. Now, we have these 2 points. We'll find out the point of inflection. So, at x equal to 1, what you are having? D cube y by dx cube equal to minus 12, which is not equal to 0. Again, at x equal to 2, d cube y by dx cube is equal to 12. That is also not equal to 0. Thus, x equal to 1 and x equal to 2 are the points where d cube y by dx cube is not equal to 0. Okay. So, if x equal to 1, what is the value of y from the function? So, it is 19. And if x equal to 2, what is the value of y? It's 33. So, how you are going to get that value? By substituting the value of x here. Right. So, therefore, the points of inflection are 1, 19 and 2, 33. Now, we shall solve the problem, one more problem in the same manner. You can go through this problem. Find the range of x for which the curve is concave upwards or downwards for the function y equal to 3x to the power of 5 minus 40x cube plus 3x minus 20. As usual, find out the second derivative. You will have 60x into x square minus 4. First, consider d square y by dx square greater than 0 means this must be greater than 0. So, which implies x greater than 0, x square minus 4 greater than 0. If this product must be greater than 0 means this must be greater than 0 and this must be greater than 0, or this must be less than 0 and this is also less than 0. That is negative into negative, positive. Okay. Now, we will consider this result. If x greater than 0, x square minus 4 greater than 0, which implies x greater than 0. Now, simplify this one. It's a square minus b square form, a minus b into a plus b. So this is greater than 0 means x minus 2 greater than 0, x plus 2 greater than 0, or x minus 2, if this must be greater than 0 means either these two greater than 0 or these two less than 0. Okay. So which implies x greater than 0, x greater than 2, x greater than minus 2, or x greater than 0, x less than 2, x less than minus 2, which implies x belongs to, or the interval is 2 comma infinity. Since this is not possible, this result is not possible, therefore x lies between 2 comma infinity. Again, x less than 0, x square, one more condition, x square minus 4 less than 0, which implies x less than 0. If this must be less than 0 means x minus 2 less than 0, one is negative and one must be positive, or this is positive and this is negative. Okay, further simplification, x greater than 0, which means x less than 2, x greater than minus 2, or x less than 0, x greater than minus 2, greater than 2, x less than minus 2. So x lies between minus 2 comma 0 because this condition is not possible. So thus d square y by dx square greater than 0 in the interval 2 comma infinity and minus 2 comma 0. Hence the curve is concave upwards in the interval 2 comma infinity and minus 2 comma 0. Similarly, we can find out the range for which the curve is concave downwards.